So we are recording. We are live. Mr. G Math, right, Jer? You with me? We're live. Room 7202, right? On a glorious Tuesday morning.
Taco Tuesday.
Taco Tuesday at Guerrero's. June 27th. Isn't that crazy? You're still at school. Here we go. So, we're talking about the limit definition of a derivative. So I'm going to pry your brain from a week ago. When you take the derivative, what does it mean? What are the words we use? What does it mean to take the derivative of a function? The derivative, right, is the slope of the tangent line. And the second thing we talked about was an instantaneous rate of change rather than an average rate of change. So what two concepts are connected to derivative? Slope of a tangent line, instantaneous rate of change, okay? They're connected. If you have a secant line, how many points do you use to determine the slope? If you have a tangent line, how many points do you use? In order to find the slope of a tangent line, you need a limit. Because for a limit, it doesn't matter what it is when you get there, it's when it's approaching it, right? Because when you get there, the denominator is undefined, right? We can't do it. But as you're getting there, we can do a limit, right? And find the slope of a tangent line. Now, do you recognize this and do you recognize this? Now, we're not comfortable with this symbol completely, right? The change in x. So what symbol did we use? So first of all, for a secant line, it's simply algebra, right? The change in y over the change in x. We use this. So I'm going to write it right in. So how do you find the slope using that? Is that we use it in terms of h instead of that, right? The limit as h approaches 0 h represents a second point somewhere along. So whatever number x is, you add a number to x, and now you have another point on your function. When you have 2 points, it's a secant line. When that h becomes closer and closer to 0, you no longer have 2 points, you now have 1 point, and that's what we want. Okay? So that h represents some number that you add to x to get a second point. And when that h becomes 0, we no longer have a second point, we now have 1 point. And limit allows us to find that slope. Because it doesn't matter when you get there, it's what it's approaching, right? As we do it. You recognize this of something we did last week. Yes? Yes. So that's what we need to practice. Let's see some terminology, okay? So the slope of a tangent line is called the derivative. Derivative has multiple concepts connected to it of a function at a given x value. The most commonly used symbol for derivative is this, right? We call that f prime, right? At x, the word prime. So here's f prime at x. Y prime means the same thing. This symbol we use a lot, dy by dx. The derivative of y with respect to x. That's how we describe it. Sometimes you have d of f at x by dx. The m represents the slope of the tangent line. Here are limit definitions. So, a vertical tangent line has no slope. So a curve has no derivative at any point where it has a vertical tangent line. Differentiation is the process of finding derivatives. So if you're differentiating, you're finding the derivative. If a derivative exists at a point on a curve, the function is said to be differentiable. Differentiation, derivatives, differentiable, right? They're all that same base word of derivative used in different ways at that point. So let's look at example number 1. How would you find the, and I'm going to change that change in x to just what again? H, because we like that better. So how do I find the derivative of that function using the limit definition? So do you see the function here, x squared plus 2? Instead of x squared, I'm going to put in parentheses squared plus 2. Something's going to go inside those parentheses. Do you know what it is? X plus h. Good. Then we're going to subtract. And I'm going to use parentheses again. And what am I subtracting? Just no h's, right? Just the function without an h, which is x squared plus 2. The change in y is on top. The denominator is just h. Now we have to simplify. Can I show you a pattern to square a binomial instead of drawing a box? It comes from Pascal's triangle, which I don't think you remember, because what you don't practice, right, we forget. So I'm going to remind you, and if you like the pattern, great. If you're not wanting to listen to it and you draw a box, that's okay too. So x squared, I write it down. Do you see where it comes from? So I take the first term and I square it. So what's x and you square it? It's x squared. Take the two terms and multiply them together. What's x times h? xh. And then you double it. So it becomes 2xh. And then take the last term and square it. And the more you practice that pattern, you can quickly expand a binomial squared that way by seeing the pattern. Sometimes when you take a calculus exam, the being efficient matters. Did you know that? Like when you prepare for your SAT? Do you know what I mean when I say being efficient? Right? So how quickly you get to the answer still matters. Okay, that subtract sign goes to both. So that's subtract x squared and subtract 2 all over h. If you did the algebra correctly, you should see terms that eliminate. What terms eliminate? X squared. Anything else eliminate? Nope. So we're going to write down 2xh. Does 2 eliminate?
Yeah.
Did I forget to write down 2? Because I'm silly like that, right? So this plus 2 I forgot to write down. So 2 and negative 2, that's how you can edit yourself, right? Because you know what? The only thing that should be left over is terms that have what letter in them. And if there's something else, then something else is up. So what's left over when you eliminate, so the 2's eliminate, x squares eliminate. Do you notice that every term has an h in it? That's necessary. Why? Because guess what you're going to factor out? H. And if you factor out the h, you have 2x plus h. Now, do you notice what happens to the h's? They divide out. Can you now plug in 0 for h? That's all I wanted, right? Is to be able to do a substitution, and it's not undefined. So can I substitute in now? And it's not undefined. So what's the answer? Done. Do you remember the power rule? Right? Here's the thing. Once we practice the limit definition, you still have to have that skill, but we're not going to do that skill on a regular basis. The power rule we're going to use all the time. But so you can check with the power rule that they're equivalent. What does this mean? F prime at negative 3. And what did you find? What does that mean? The slope of the tangent line when x equals negative 3 is what? Get that? The slope of the tangent line? Does that mean around negative 3 is it increasing or decreasing? When x equals negative 3, is the function increasing or decreasing? Decreasing, okay? Negative slope, right? It's going to be d. So you can get information off that. Turn the page. Here we go. How do you find the derivative of y equals root x? As a limit. And then we'll check back with the power rule. As h approaches what? 0. What is it? Instead of the square root of x, what goes in place of x? X plus h minus f at x, which is root x, and that's all over h. How do I simplify this? Do you see the numerator? Do you remember what we use when we have square roots? It's not factoring. What is it? The conjugate. I heard it. Thank you. What's the conjugate of the numerator? Plus, right? What you created is called the difference of squares. The denominator, I am not going to distribute. The denominator, I'm going to leave alone. They're just going to go beside each other, okay? But the numerator, how do I handle this? How do I multiply the two binomials on top? Because it's a difference of squares, I go first times first. The roots, when they multiply together, leave you just with what? And then root x times root x is just minus x. If you did it right, what should you notice? Is that a term should eliminate, right? Do you see something that eliminates on top? X. And what are you left with? H. Now, do you see the h's divide out? What number don't you see that's left in the numerator? And now, can you plug in 0 for h? So when you plug in 0 for h, what are you left with? X plus 0 is just x, right? Do you know another way to write root x plus root x? 2 root x. Awesome. Just because we're like this, we're going to practice with the power rule to see if we did it right. Is that okay? The only way I can do the power rule if it's written as a what? I can only use the power rule if it's written as a exponent. How do I write root x as an exponent? Okay, what's the power rule? What goes in front? So 1/2 times 1, and then what do you do with the exponent? Subtract 1. What's 1/2 subtract 1? Negative a half, right? What's 1/2 subtract 1? Negative a half. Can you write this and notice it equals the same thing as this? So in other words, what goes in the denominator? See the 2? That's in the denominator. What does a negative exponent mean? It also belongs in the denominator. And x to the 1/2 is the same as root x. What do you notice? They're the same. All right. Number 3. Switching up the letters on you. Can you do this with respect to t? So now we have x, we have t. What would the limit definition mean here as h approaches 0? What do I start with?
2t plus h.
Well, the function is what? 2 over t. So it's going to be 2 over t plus h. So replace the t with t plus h minus what? And that's all over what? H. This is not a square root. This is not a candidate to factor. Instead, what do I do when I see this to simplify it? I need to write the numerator as one fraction. How can I write that as one fraction? I need common denominators. So if I look at the first fraction, what's missing that it needs? A t. And I'm going to multiply top and bottom by t. The second one, what is it missing so the bottoms are the same? T plus h, top and bottom. Now, can I write the top as one fraction? So our common denominator is t plus h times t. And you can do that in any order. What happens in the numerator? What's 2t minus 2t? And then what's left in the numerator?
2h.
Negative 2h. Sometimes the algebra is more complicated than the calculus. Right? How do I divide fractions? You multiply times the reciprocal. So write the first fraction. And then what's the reciprocal? Right? The reciprocal of h is 1 over h. What do you notice about the h's? They divide out. Now, can I plug in 0 for h? Yes. Okay, what am I left with on the top? Negative 2 times 1 is negative 2. What happens when I put in 0 for h? T plus 0 is t, and then t times t is t squared. And that's it. That's the derivative. Guess what I'm going to do? I'm going to test it with the power rule. In order to use the power rule, I have to write that as an exponent. How do I write 2 over t as an exponent? What would it look like? 2 over t is the same as 2 times t to the negative 1. Do you believe that? The t in the denominator can be written as t to the negative 1. You better stay with me. If you don't write it as an exponent, you can't use the power rule. Now, what is the power rule to take the derivative? Negative 1 times 2 is, and then subtract 1, and negative 1 subtract 1 is that the same as this? Are they equivalent? Which one would you use if you had a choice? Would you use the limit definition or the power rule? Duh, right? Okay, number 4. Here's the same limit definition, but if you're asked not to find the general derivative, but you're asked to find the derivative at an x value, right? Find the derivative at a certain x value, and that's all you needed, right? There's a different definition we could use. Do you see it here? It's just f at x at f at whatever the number is, all over x subtract that. So, let's look at it. What's the x value we're looking for? 3, right? Do you see it? So we're going to go as x approaches what number? 3. The bottom is going to be x minus 3, right? All from that different definition. The numerator is f at x, which is x cubed, minus what? F at 3. Well, what is f at 3? 3 to the 3 means 3 times 3 times 3, which is... Can you factor a difference of cubes? Yes or no?
Yes.
Go for it. I love that. I forget the formula for the difference of cubes. So what can I do as an alternative if I don't know how to do a difference of cubes? You know what I'm going to do? I'm going to divide. So if you know a difference of cubes and you've memorized it, that's awesome. But I'm going to divide the bottom into the top using synthetic division. What did I do? 3 times 3 is not 6. 3 times 3 is 9. And then 9 times 27 is 27. What did you notice about the denominator? It goes in evenly, right? And what am I left with? X squared plus... Can you now plug in 3 for x? Yes. And that's 9 plus 9 plus 9. So do you notice, honestly, you know how to factor out a difference of cubes by memory? Or can you just divide, right? Whatever it is. So, do you know how the limit definition of a derivative be able to apply it?